What is going on, guys? Welcome back. In this video today we're going to go through a full data science project for predicting employee attrition. So let us get right into it. Alright, so we're going to go through a full data science project today. We're going to train a machine learning model to predict employee attrition. Now, what is employee attrition? I looked up a definition here. It is defined as the natural process by which employees leave the workforce, for example, through resignation for personal reasons or retirement, and are not immediately replaced. So this can be interesting for companies to predict how many or which employees will probably leave the company and not be immediately replaced. That's the basic idea of this project. For this, we're going to use a data set from Kaggle, the IBM HR Analytics Employee Attrition and Performance data set. Now, as far as I understand it, this is artificial data. I don't think that this reflects actual HR data. Correct me if I'm wrong, but of course you want to apply this if you have a company onto your own company. But it's enough for this project. We're going to take a look at this data set. We're going to explore it. We're going to pre-process it, and then we're going to train a machine learning model on it to predict employee attrition. So I already downloaded the data set and extracted it. So I have the CSV file here. And this is what we're going to work with now. Now, before we get into the code, we need to also make sure we have all the necessary packages installed. For this, we're going to install pandas, we're going to install NumPy, we're going to install matplotlib, and we're going to install scikit-learn. I think that should be it. Let me just double check my prepared code. I think that we don't need anything else. So these are the packages that you want to install, and then we're going to start by importing pandas as PD. Now, the first step is always to explore the data set. So we're going to say df equals PD read CSV, and we're going to load this CSV file here, and then we can take a look at it. Now, taking a look at it means we're going to take a look at all the features to somehow decide what we're going to do with them. Now, in order to do that, you can see I cannot see all the features here because it says ... and just looking at the column names is not really enough to understand the features and how they're structured. So what you can do here is you can say pd.options.display.max rows, and you can set this to 500, for example. And then we can look at the data frame. This will, or actually, not max rows, sorry, max columns, because we want to see all the columns, not all the rows. And this allows us now to see all the columns here. All the columns are displayed. There is no ... in between. And the first thing I always do when I explore a data set is I want to look at the features. Which of these features can be used right away? Which of them have to be pre-processed? Which of them are maybe useless and need to be dropped? Now, what I notice right away is that this here is my target variable. The attrition is what I want to predict. I want to predict a yes or no. Is the person going to leave the company or not? Attrition, yes or no. I also immediately notice that this is not a value that my model will handle right away. So this needs to be pre-processed. This needs to be transformed into a binary feature, into a 1 or 0. That's already one thing that I notice. Besides that, I see a lot of numerical features. Now, just because a feature is numerical doesn't mean that it can be used right away or it should be used right away. I don't think that this is the case in this data set here, but oftentimes you might have features, categorical features, that are represented by numbers. So for example, you could have something like education field, but instead of having these words, you could have 1, 2, 5, 7, and so on, representing individual fields as IDs, so to say. So 7 could be, I don't know, life sciences, and 2 could be medical, and so on. The problem with a feature like this is, even though it's numerical and you can feed it into a machine learning model, it doesn't make a lot of sense to do that because it's not on a spectrum. So you're not going from low to high, because maybe medicine is 0 or medical is 0, 1 is technology, and then 2 is biology. And even though 0 and 2 are closer together in real life, they are not closer together in on the numerical spectrum here. So oftentimes, numerical features are also categorical features, and in this case you don't want to have them as one feature. You want to one-hot encode them as multiple binary features, which we're going to talk about here in a second. But I think that most numerical features here are actually on a scale. So if we look, for example, on age can be kept like this, because an age is a feature that goes from small to high, or from from small to large, from low to high, it makes sense to have this on a continuum. And you also have distance from home, you also have education. These things make sense as numerical features because there is a continuous progress. You can have a higher education or a lower education. It's not like you have categories that are not on a scale. Employee count is something that we can look at. Right now it looks like all of these values are 1. Employee number is completely irrelevant. The number of an employee should not be part of the evaluation here, because who cares what number you got in the company? The important thing is, are you going to leave it or not? And this will probably not depend or should not depend on the number. Unless, of course, the number is somehow correlated with how long you are already at this company. Then satisfaction, also on a scale, can be kept as a numerical feature. Gender is a feature here that is categorical. So in this case, we're going to encode it as a binary feature. For example, male could be 1, female could be 0. Hourly rate is also something that is on a scale, so it can be kept as a numerical feature. Job involvement, job level, the same. Role is again categorical feature, and the categorical features we're going to one hot encode. Now, what does it mean to one hot encode a feature? Let me just show you an example here as a comment or in Markdown. Let's say I have jobs and I have programmer and I have designer and I have clerk and I have maybe one more. Let's go manager. What I can do now if I have a feature like this is I can just say I have a job feature and the value is programmer, or I can one hot encode the feature, which would result in having 4 different features: programmer, designer, clerk, and manager, which can each be 0 or 1. So for example, I would have programmer, in this case would be 1, designer would be 0, clerk would be 0, and manager would be 0. So basically that's the idea. So this is one hot encoding of features. We're turning categorical features into multiple binary features. Of course, this only makes sense if you don't have an endless amount of different positions here, but for the most part, this is a reasonable way to do that. We're going to do that also for the marital status. We're not going to do that for the satisfaction or the income or the rate. We're not going to do it for this. This here, over 18 is a yes or no feature, so we're going to just binary encode it. Yes will become 1 and no will become 0. Overtime, same thing. Yes will become 1, no 0. Then we have here again numerical features on a scale. This makes sense. This all makes sense. And these can also all be used right away. So we have a bunch of features that we need to one hot encode. These here, we have a bunch of features that we need to binary encode, and we're going to definitely drop this one, and then we're going to explore further to see if we have to drop additional features because they have only one value or something like this. So let's get started by saying which columns are we going to binary encode. So let's just type this here as a comment. The binary columns are going to be obviously attrition, so our target value variable, attrition. Then we're going to need gender, as we saw. So there you go, this one here. Now, if you want to make sure that you actually have a binary feature here, so for example, in some data sets, gender might not be binary. You might have 5 different values. In this case, what you want to do is you want to say data frame gender value counts. Or is it value count? No, value counts. In this case here, you can see we only have 2 values. When you only have 2 values, you can model it as a binary feature. If you have multiple values or more than 2 values, you want to one hot encode it usually. So in this case, gender can be modeled as a binary feature, and we also saw over 18 and over time. These are also binary features. And besides that, all the features are either numerical or categorical. So what we're going to do with those 4 features is we're going to say that we want to map, we want to apply a function to them. So for the attrition, we're going to say df attrition is df attrition dot apply lambda expression x, and then we're going to say 1 if x is equal to yes, else 0. Now I can do that for all the columns. I can do that for gender and for over 18 and for over time. And then again here The only difference is, of course, what you put here, because in this case we can say male. In this case we can say Y. I think this was Y, right? Yeah. And for overtime it was yes and no again. So we can do it like this. Then we can print the data frame again. And now you can see we have these as binary features. So now we don't have any words in there, but we just have zeros and ones. All right, now for the one-hot encoding, we're going to use Panda's getDummy function or getDummies function. But first of all, let's again collect all the columns. So for one-hot encoding, we're going to use the following features. Business travel is going to be one. The department is going to be one. The education field is going to be one. The job role is going to be one. The marital status is going to be one. And I think that should be it. Let me just double check with my prepared code if that was also what I did in the preparation. I think so. So what we're going to do now is we're going to use the pandas getDummy function, getDummies function. For this, we're going to say pd.getDummies, and we're going to pass a column. For example, df business travel, like this. What this is going to do is, as you see, all the values of business travel, which are non-travel, travel frequently, and travel rarely, will be turned into binary features. So we have false or true for the individual columns here. Now what we want to do now is we want to take them and we want to join them with the original data frame. So I want to say df join these columns. So now what we have is we have the business travel feature here, and at the end we now also have three new features, which are the business travel feature one hot encoded. Now of course we want to drop this one here, so we're going to say dot drop business travel axis 1, because we're dropping a column, and then we're going to result, or this is going to then result in this data frame here. So we only have the new ones and not the old ones. And if you actually want to apply this now, you say df equals df join. But before we do that, I want to show you also that we can add a prefix. Now for this one, I think it's not really necessary, because when I look at non-travel, travel frequently, and travel rarely, I already know what we're talking about. But maybe with department, we want to do it differently. So pd getDummies df department. That is, this, for example, sales. What does it mean now, sales? It could mean anything. It could mean a number of sales. It could be any feature. So what I want to do here is I want to say prefix equals department. And what this is going to do is it's going to name the features department human resources, department research and development, department sales. So this is just a small thing that we can change here, df join, and then drop. And I want to drop here department axis 1. Now we can copy paste that, or actually before we do that, let me just say df equals and df equals, and then copy paste this. And we want to do that now for all these one hot encoded features. So education field is going to be education prefix here. We're going to drop education field afterwards. And we're going to do the same thing now for job role. Job role, job, or actually let's just call it role, job role, and then finally we have marital status, prefix is going to be status, and marital status will be dropped. So just run this, and then when we take a look at the data frame, we can see that there is no feature left here that is not completely numerical. Now these here are booleans, but we can easily convert all of them into zeros and ones by just saying df, so let's say df equals df map, and we're going to map the following lambda expression to this data frame. We're going to say 1 if x is true, else 0 if x is if x is false, else x. This is important that we combine these two statements, because otherwise everything will be turned into 0, 1. even if it's, for example, 1102, because if it's not true, then it's, for example, this, and it will also be turned into 0. So what we want to do is we want to say 1 if x is true, else 0, but only if x is false, otherwise x. So that is going to turn literally now all the features into numerical features, into numbers, into zeros, ones, and everything above or below that. Usually, I think, just above that. And now the next thing we need to take a look at is what do we want to drop? Now we said we want to drop the employee number because it's not important. So we're going to say df equals df drop, and we want to drop the employee number, axis equals 1. And then the next thing we want to do is we want to print, or we want to plot a histogram of the data so that we can see if some features are so skewed that they're basically useless. So we're going to say here import matplotlib.pyplot splt. I'm going to say plt figure size, or actually I don't need the figure, I can just say directly data frame hist for histogram, and here now I can pass the figure size. I'm going to use 20 and 15, and then we want to do plt tight layout, plt show. And this is going to then give us a visual image of the distribution of the features. So here you can see all the features and you can see their distributions. So age seems to be somewhat normally distributed. Attrition seems to be skewed, but it's okay. Daily rate, distance from home. So all these seem okay. Employee count is suspicious. Why? Because we only have a single bar. So it means this feature is completely irrelevant. There's only one value in here. So this is one I want to drop. Then we can look at all the other features here. What do I have? Over 18 also seems to be a feature that only has a single value. So this is the next one I'm going to drop. Then standard hours also seems to be 80. So if it's 80, just drop it. If it's always 80, just drop the feature. And then you can, think about all these skewed features here. But of course, since they are one hot encoded, it makes sense that most of them will be 0 and just a couple of them will be 1. But maybe you want to drop certain features here as well. All right, so what we're going to drop is employee count, over 18, and standard hours. So I'm going to say here df is equal to df drop, and I'm going to drop the list of the columns here, axis equals 1. I'm going to drop, as I said, employee count. I'm going to drop over 18, and I'm going to drop standard hours. And now, hopefully, if I run this again, I will see only features that have at least 2 different values. Yeah, okay. So that's it for the pre-processing. Now let's go to the model training. Let's add a small heading here, model training. And since this is a structure here that seems like decision making. Now, if you were to analyze this data, let's say you're an expert, you want to analyze this data, what you would do here probably is you would look at the different features. You would say, okay, satisfaction is above a certain threshold, education is above a certain threshold, the age is above a certain threshold, this is below a certain threshold, and so on. Maybe you consider the gender, maybe you consider other things, the income is that high. So with all this data, after going off the different branches of this is higher than that, lower than that, I decide that this is going to be a yes or a no. And this structure is basically a decision tree structure, and because of that, we're going to train a random forest classifier because it combines multiple decision trees into a forest, into an ensemble, and this is usually a pretty powerful model. So I'm going to say here from sklearn.ensemble, import random forest classifier, and also from sklearn.model selection, import the train test split, because we need to have a split that is going to split our data into training and testing data so that we can evaluate the model. So I'm going to say here the X data and the Y data are going to be equal to the data frame after the attrition is dropped. That is going to be our X data because the attrition is the target variable. And because of that, of course, Y is going to be df attrition. Then we want to split it into training and testing data. Xtrain, Xtest, Ytrain, Ytest is going to be equal to train test split, and then X, Y, and the test size is 0.2. Now for reproducibility, you could specify a random state, so a seed. In this case, you would always get the same result. The problem is a lot of people like to deliberately pick seeds or random states when they initialize a split or when they initialize a random forest, and then they can artificially get a good result because they choose a seed where they get a high accuracy. I don't want to do that, so I'm going to leave it up to randomness here. And then I'm going to say the model is equal to random forest classifier. I'm going to use all the cores available, so njobs is going to be equal to -1. And then I'm going to say model fit xtrain, ytrain, and that trains my random forest classifier. Now, I can also take a look at, or I can now evaluate it and take a look at how well it performs. I can say model score xtest and ytest. And this gives me right here an 86.73% accuracy, sorry, which is quite good considering that we have a 50-50 chance if we just guess. And also the data is quite skewed because most people get a no. So I think that this is actually, oh, now we get 87, 83, so something around 85, I guess. Probably if you choose the right random states, you can get this above 90% as well, but that's not what we're here for, obviously. But what I want to do also here is, and I think this is the important thing, is not just having a model that does the prediction. This is nice to have. I also want to see what factors are the most important when it comes to the decision making. And random forest classifiers have the good thing about them that they show you the feature importances. So what you can do is you can say model.feature importances, and you get the values for the feature importances. Now, these are just values. These are just numbers. So what we can do is we can zip them together with the feature names. So feature names in, feature importances, and then we can display this as a dictionary, and you can see the feature importances for the different features. But even better than that would be to sort this, so to turn this into a list, and actually to just to sort it, and to sort all of this based on the values. So the key is lambda x x1. This sorts it by the second value in the list, in the tuple, and we do that in reverse order. And then in the end, we take all this and turn it into a dictionary. So that now gives me all the feature importances from highest to lowest. And it seems to be the case that how much a person earns per month is the most important factor when deciding if that person is going to leave the company and not be replaced or not. Age seems to be the second most important. And then you go total working years, daily rate, monthly rate. So all of these here are income related. The distance from home also seems to be important. Now, if you want to see a more visual representation of this, we can easily do that by just saying import matplotlib.pyplot as plt, and then we can say plt figure size is going to be 20 and 8, and here now plt xticks, or actually let's do the plotting first, plt bar. We're gonna use the sorted, or did I actually save this? No. Let's save this as sorted importances. Sorted importances dot keys and sorted importances dot values. This is going to be our bar plot. Now you're going to see that the styling is going to be very problematic here. So what we want to do is we want to rotate the xticks. So we're going to say plt xticks rotation is going to be 45, and horizontal alignment is going to be right. And this is going to result in that. Now, finally, let me do a plt show. There you go. And you can see now visually how much the difference is. So monthly income is the most important one. Age seems to be important, and total working years, daily rate, monthly rate, which are probably very highly correlated. Distance from home and so on. And then you can see the features get more and more irrelevant. Something like the role seems to be not very important. So in general, there's no role here that seems to be super important. Sales representatives seem to be either not leaving or leaving a lot. But yeah, this is how you can analyze also the feature importance, and you can now use the model for making the prediction in your company if you have a real world data set with, in this case, 83. If we do it a couple more times, 88% accuracy. This is kind of good. Yeah, and if you want to get even better, you can also do hyperparameter tuning if you want to. I have a video on this channel if you want to check it out. But this is how you can predict employee attrition in Python. So that's it for today's video. I hope you enjoyed it and I hope you learned something. If so, let me know by hitting a like button and leaving a comment in the comment section down below. And of course, don't forget to subscribe to this channel and hit the notification bell to not miss a single future video for free. Other than that, thank you much for watching. See you in the next video and bye.